Now, without further ado, I would like to introduce our first speakers for today, and we are excited to have a roundtable discussion with Dane Gobel from the Deep Space Food Challenge, and Anjan, Contractor from BeeHex, and also our very own Alex Shirazi from the SVCMS group. Dane, Anjan, and Alex will be talking about developing new food technologies for space. And with that, I would like to hand it over to Alex.
Great. Thank you very much, Anita. And I'd like to thank those who are in the audience tuning in, and also Dane and Anjan for being here today as we really explore topics of future food technology in space. And so to get started, I want to send it over to Dane. Maybe Dane, you can give a quick introduction. After we all do intros, we can dive a little bit deeper into the Deep Space Food Challenge. But go ahead, Dane.
Oh, sure. Thank you so much. And I'm so happy to be here. This is really cool. I was lucky enough to have a conversation with Anjan a couple of weeks ago at Clubhouse. So we get to do the protracted instant replay of that. But yeah, so I'm Dane. I'm with the Deep Space Food Challenge. I'm with specifically I'm with the Methuselah Foundation, which is the allied organization for NASA's leg of the challenge. So the NASA and Canadian Space Agency have put out two separate, extremely cool prizes with largely shared rules, and slightly different timelines, slightly different eligibility requirements, slightly different prize purses. But they are absolutely amazing, and I think they're at least the way that I think about it is a little bit like these agencies have kind of opened the door just a crack, and it's up to the people, the innovators in the industry, to actually kind of kick the door open when it comes to actually revolutionizing food, both for people in space, but then also for people on Earth, because whatever technology you make in space can be refangled for terrestrial purposes. So specifically for the prize, and I won't talk for too long, but specifically for the prize, the goal is to fill food gaps for a crew of 4 for a 3-year mission, presumably to Mars. So the food lab, the NASA food lab, and what currently exists in the ISS is really, it's truly amazing what they've been able to do with thermostabilized foods. But they're kind of reaching the point where they understand that there's some pretty hard limitations for what they can do. And so they are looking for more novel solutions, which Anjan had kind of built his career around. He did like some incredibly cool stuff with 3D printing. But they're looking for more novel solutions, both in terms of growing food in space, but also, things like 3D printing, more personalized nutrition. There's really a lot of opportunity there. And because the resources are so scarce, the environment is about as harsh as it gets, space wants to kill you. You have the opportunity to have a sufficiently difficult problem where you, by definition, have to create truly amazing technology in order to survive it. So I'm really, really excited to be involved in it. And I think that the prize as it is, short term, is going to do amazing things for space exploration, but long term, it's going to have a transformative impact in terms of how we even think about food and how we think about decentralized food distribution, not having supply chains that you have to worry about breaking down so much. So you're going to end up, hopefully, solving for food gaps, not just in space, but also the growing food gap here on Earth over the next several decades. So yeah, I think that's the goal behind the prize. And I should also say before anything else, these are my opinions and my opinions only, not NASA's. And also to make sure to check out Grace Douglas's work if you haven't already. She was with CMS last year, I think, and she did like an absolutely incredible primer on what the current situation is. So popular level, but also very, very technical, really, really good stuff if you want to understand what the situation is. Whereas the rules don't give quite as much color. They're talking because they're trying to be minimally constrained. So make sure to check out the work if you want to get the full picture. So that's my spiel. I will stop talking now.
Great, and that video from Grace Douglas's talk is in the general channel. It's pinned in there, so if you are looking to dig it up later, it'll be in the general channel of Slack. Now passing it over to Anjan, it'd be great to kind of hear about your background.
Yeah, thanks, Alex. Dane, great background. Thank you for that. And it's been truly a pleasure to be here. CMS Astro and We have a lot of participants. Thank you very much for hearing me out. My background is in additive manufacturing. I've dedicated almost entire career in or around additive manufacturing, robotics, automation, and developing newer materials for additive manufacturing. And 3D printing, the word 3D printing came slightly later. It evolved around 2006, 2007 when RepRap open source 3D printing movement came about. But I'm more comfortable with additive manufacturing because that's how I started my career. But my major work with additive manufacturing, or a breakthrough work, was when I was subcontracted a project to develop a system that can personalize diet for astronauts, especially during deep space missions. And that was around 2011, 2012, when NASA had just scratched surface of putting together details of what would it take, what sort of systems, what type of food ingredients would it take to send astronauts beyond higher Earth orbit when space missions are 6+ months. And that time, I was very much involved in developing a softer material for that can be extruded with 3D printers. And the idea came about, and I discussed with quite a few scientists at my previous life, my previous job. And we wrote a proposal to NASA, which was taken very positively. And the idea was that NASA has already been working quite a bit on dehydrated ingredients with microencapsulation. So when there is no water in this sort of food ingredients, it reduces weight quite a bit, and it gives a leverage of variety types of packaging. You could compact this sort of dehydrated ingredients into small capsules and then rehydrate them and make paste, and then use some sort of system, let's call it 3D food printer, because that particular word became very popular after my development with NASA. But I just call it a system that rehydrates the food and recreates palatable textures that is truly personalized for each and every astronaut. So when I was working on it, we were very successful in our phase 1, and then it was moving to phase 2, and the funding was cut for several reasons. And I was so much attached to that project that I decided to start my own company. And so I quit my job in 2015 as a NASA subcontractor. I also had a few projects with Air Force and with Skunk Works, and decided to be by myself. And I received funding from quite a few angel investors, from venture capital, and I developed system for application here on Earth using 3D food printing. Now we are doing quite well. We are on our growth trajectory. We have a whole product line that is applicable for baked goods. Nothing close to what I was working on for NASA. Much simpler system. They're still very complicated, but they are very robust. You know, they can produce in a very harsh environment of industrial bakeries and produce millions of products. You know, we have our products in Canada, about 8 different states here in America, and also in Mexico. And we'll be installing systems in United Kingdom and also in Thailand within the next 6 months. But now, you know, when Dane came back to me and started discussing about his initiative for the Deep Space Food Challenge, I was super excited. You know, this is something coming back to my memories. And you know, when the first investor invested in us, the first lead investor, one of his dreams was to start a space food institute here in Columbus, Ohio, and put together a consortium of companies, food producers, food equipment manufacturers, and together provide food and food systems for space missions. So that's my background in a nutshell. And again, I'm very excited to be here, and you can pick my brain in any capacity you would like.
Great. It's really exciting to kind of hear about what it actually entails to take these, I want to say experiments, but kind of, projects into space in this limited environment. And so the first question is really about, startups and funding. When we talk about space, usually big budgets are involved. Can smaller startups with limited budgets actually make an impact? And if so, how? And open the floor for anyone that wants to kind of jump in on that.
Well, Dane, you want me to start on this since I have a startup?
Please.
Okay, all right. So Alex, you also have a startup, and I also have a startup. The problems of, or growing pains of putting your product in the market. But only startup can accelerate at the growth that is needed for this particular space food challenge. And this challenge is not the challenge that Dane, it's a bigger scale challenge in general. And the reason I say that is because we as a collective startup ecosystem, or even NASA as a space agency, realize that we have overlooked what sort of resources and systems that would require to send astronauts to Mars. How do we break it down into small stages, testing at Womit Comet, from there to testing it at ISS. If there is a moon lab in next 10 years or so, how do we test the food and food systems over there, and then expand to a deeper space, higher Earth orbit and beyond, before we even talk about Mars, right? So since that whole breakdown of tasks or objectives or vision wasn't there, now the only, let me reiterate, the only entity that, or entities together, that can make this happen are startups. And because the way they can move, the way they can leverage the hustle they go through to make this happen is something that a large company may not be able to do so. Now, I'm not undermining large companies, because startups will need to partner with large companies. They need to go and leverage their resources, not only resources, but their expertise. When we design systems for space, what are the specs? What are the criteria to even connect two wires together? What sort of weight and dimensions of the food systems are allowed? How can we reduce weight? All these challenges, of course, startup can do it at a faster pace, but without the help of larger companies with a tremendous amount of experience, it is next to impossible. So it should start from startups, period. But with the collaboration of larger companies. That's my take.
Yeah, I think you're right. I think it's a matter of how you bridge all of those gaps and what the trajectory is. So the one thing that's cool about this challenge is its current phase. It's similar to like an SBR1, where it's a design application. So whether you're a small team and you have the resources to just put one idea in, or you're a company that's more of an established startup and you have a more dedicated R&D department who has a variety of different approaches that they're playing around with, it gives you the opportunity to kind of put together a portfolio of ideas to put before NASA. So one of the other things that's cool about this prize is it's not talked about it too much, but NASA reserves the right, even though like a 25K. Okay, so I actually should say this real quick. So the current U.S. prize pot is 500K, which is like not much, right, for a prize like this. This is, to me, like, this is a moonshot problem, and they're trying to make the bets that they can in order to push it in that direction. But really, what needs to happen is the technology needs to show up, and there needs to be a groundswell of interest from private investors and from the public in general, I think. And I do think, just real quick to say this, I think it is a cool way of kind of flipping the narrative a little bit when you talk about food scarcity. You're able to have it be something that's a little bit more aspirational than something that's talking about a sad problem. It's this is an opportunity for us to go further into space and have the technology that's developed there change the Earth too. But just to quickly say that when you've got, it's only a 25K thing, but the amount of public interest that can be gleaned from that, the amount of promotion that comes from it is really positive, and then you're able to move into further stages. And of course, by getting NASA seal of approval, it makes it much easier to raise private capital. So I think really, as far as the prize is concerned, NASA reserves the right to non-exclusively license the technology from the get-go. So it's a nice way to kind of skip the federal acquisition process and put a whole bunch of ideas in front of NASA to increase the likelihood of success and attraction from private investors. So prizes are cool because they're a big attractor, depending on your pick your metaphor, whether they're a lightning rod or gravitational attractor, whatever. But they can often be a strange attractor where they're perfect for startups, people who may not have the amazing connections, they didn't go to the right school or whatever, but they have a fantastic brain and an awful lot of energy. They can make amazing stuff very quickly and leapfrog more established entities who behemoths that can't move. They move at the speed of mud. So yeah, Anjan, I appreciate your experience there. You've definitely been here before, and especially seeing what happened with you and how you had to actually focus on the terrestrial impact entirely is very interesting to see that. And so I think for this prize, it's cool because it's oriented around space, but especially Canada is in particular interested in the terrestrial application because they have so many people in really isolated, harsh environments in the far north. And so what you make in space, what you make for space, is often going to have some really fantastic impact for those isolated communities. And as far as the specifics of the rules are concerned, it's minimally constrained. It does not require that it has to work in microgravity. So that opens the idea space up significantly. So I think the assumption is that they want to reach out to people who are in the food tech industry who may not know how to build something that can work in microgravity. They want to get as many ideas as possible and then have the ability to perhaps adapt them for their specific needs. So in every case, I mean, they're trying to be extremely open-minded and methodology agnostic. And they're trying to make it as easy as possible for as many ideas to come in.
That's great. And I think a nice segue to the next question, which is really, about how to really get access to these space agencies. Like outside of the challenge, what is the best way to connect with NASA or CSA or some of these other space agencies? And then before I open up, I just want to say, Anjan, the fact that you said, startups are the ones that are going to make this happen. Like, I think that should be very inspiring to everybody in the audience, because I just see a very exciting next 10, 20, 30 years ahead. But so back to the question, what is the best way to approach NASA or these different space agencies outside of just these challenges?
I think what Dane has done is the best way to connect. I highly encourage whichever entity, small companies, large companies, startups, are interested in connecting with NASA should participate into this deep space mission for future of food in space challenge. And apart from that, NASA also comes up with a variety of problems in the realm of SBIR framework. Those who don't know what is SBIR, it's a small business innovation research program that NASA brings forward in terms of solicitation. It's available to any company that is less than 500 people and considered as a small business in the US. And they can take a look at what areas are critical for NASA's near future projects and distant future projects. And if they are applicable, I highly encourage them to write a proposal. That's the best way to connect directly with the principal investigator researchers at NASA. And once they dive into at least phase 1, phase 2, it will open up newer opportunities. Many times, the small companies and startups can bring together a newer vision that may not be within the framework or realm of NASA White House office. They are very open-minded. Most of the researchers that I've talked to at NASA, they always like to see white papers. They always like to hear your opinion. Once you have your one foot in, either by SBR phase 1 or a competition that Dane and his group has put forward. So even though, let's say, one of the, any company that cannot get into this competition, they should be able to come in contact with NASA and Dane for future correspondence.
Thanks, Anjan, for the vote of confidence. I should say it's not my challenge. I'm very, very lucky to be involved in it. But the guys at NASA and CSA have cooked up something absolutely incredible, and we're just here to shout from the rooftops, I guess. But yeah, absolutely. Anybody in the room who wants to get in touch with me, and I can answer any questions you might have. And if you have some hyper technical questions, I can make sure that they get to the right people. So yes, absolutely. We're looking for as many people as possible to participate and bring forward as many different novel, wild, and crazy ideas as you can think of within the constraints.
Great, thank you. And so we have some questions coming in, but we're just about out of time. There's one question from an anonymous submitter that says, is a non-exclusive license agreement nullified if they're not granted the prize? So maybe just a quick answer to rephrase, what kind of licenses are there if you do submit? Who really kind of has control over any type of IP or licensing?
Yeah, so you keep all of the IP yourself. It's just NASA basically wants to be your customer if you have something really, really cool. So non-exclusive, no IP. It's basically just, please, we'd like your stuff if it's awesome. We'd like to use your stuff if it's awesome.
Great. And then we have a question from Claude, who's asking about atmosphere, the different atmosphere of environments and how they impact ingredients in space and what it would need to have. And, for example, can the same food on Mars be served on the moon? Any quick insights on that?
That's a really great question. Anjan, you probably know better than myself, but I do know that the nutrients degrade differently. I was actually watching something cool last night where it showed the rate of nutrient degradation over time, and specifically tied to food that's on the ISS food lab. And it just shows that, yeah, after 1 year, basically half of the food becomes non-viable. After the second year, it drops to like 20 or 30%. At the third year, it's like 10. And then when you're talking about like 10%, right? So this is like basically like there's no way to satisfy the variety requirement, and then the amount of nutrients that you have available don't work. And of course, it's the same problem that you have with supplements. That's why they don't worry so much about supplementing wildly in space, because the vitamins in the supplements break down as well. Go ahead, Anjan.
Yeah. So, I mean, I will go a little bit deeper into this. So each ingredient, for example, if you talk about ascorbic acid, its decays very fast. If you put ascorbic acid in a liquid form directly from a fresh ingredient, it will start decaying in 30-40 minutes under oxygen and temperature. So as I mentioned, the environment and the temperature affect the food decay directly, any micro or macronutrients. There are some micro and macronutrients, their half-life or their shelf life is pretty long under ambient temperature and ambient environmental conditions. Now, keep in mind, one thing is that wherever astronauts go, this particular type of food, whatever you propose, will be under the same condition as astronauts are living or breathing the air. So it will be ambient. That condition will be ambient. So now you have to think about the third factor, which is radiation. Radiation is a huge factor of any micro or macronutrient decay. In fact, radiation is one of the biggest factor when you go to higher Earth orbit about how it impacts all the food system, not only the food system, but electronics, the human organs and human skin, human eyes, the hair, so many different factors. And as you go closer to sun, that radiation also is amplified. It doesn't, and radiation penetrates through a lot of barriers. So the radiation shield is something that is a whole new subject within NASA. They spend so much money in researching variety of radiation shields that can shield electronics, the human body, a variety of different systems, including foods. So what I would look into, if I were you, would be radiation as a major factor in decay of any nutrients.
Great. Well, thank you so much. You can learn more about the Deep Space Food Challenge at just deepspacefoodchallenge.org. We'll be putting that link and others in the Slack channel. And there are a couple more questions here. We're going to be migrating them over to the questions for speaker Slack channel. Thank you so much, Anjan. Thank you so much, Dane. We look forward to continuing the conversation over on Slack. For now, I will pass it over to Anita, who will introduce our next speaker. Thank you very much, guys.
Thank you so much.
Thank you so much.